So in this video, we'll look at the proof of the Angle-Side-Angle Congruence Theorem. So suppose we have two triangles, ABC and DEF, and we know that two angles in those triangles are going to be congruent, and we also know that the side in between them are going to be congruent. Then that's really enough to say that the two triangles themselves will be congruent. So here's our setup. Suppose that we have angle CBA is going to be congruent to angle EDF, and we know that angle ACB is going to be congruent to angle FED. Then we also know that the line segment BC is going to be congruent to the line segment DE. Now, the proof technique that we'll use for this problem is superposition. So we're going to take one triangle, and the idea of superposition is that because our line segment BC is going to be congruent to our line segment DE, we can superimpose those two line segments on top of one another. Now, what happens when we do that, because our angle CBA is congruent to our angle EDF, it means that our two rays, that our ray passing through BA and our ray DF will coincide. So when we do that, what that means is that points A and F will actually be on our line segment that passes through DF. Now, also, if we look at the flip side of that, when we superimpose our triangles, if we look at the ray passing through EF and the ray passing through CA, when we superimpose our triangles, again, those rays will coincide as well. And so what that means is that our points A and F will once again lie on our line passing through E and F. Now, our Incidence Theorem 1 says that we have two lines, and those two lines intersect. They're only allowed to intersect at a single point. And so what that means, that after superposition, because we have points A and F on the lines E and F and DF, then that really means that exactly what we're seeing here, point A is actually going to coincide with point F. Now, what that means is that our line segment AC is going to be congruent to our line segment EF. And so we have that our triangles ACB is actually going to be congruent to our triangle FED by our side-angle-side postulate.